Welcome guys to today's class. In today's class, we want to discuss or solve an important calculation in practical chemistry, as you can see on the board. Yes, but before then, let's remind to ourselves those important things we do when it comes to practical chemistry. Let's check some of those things we can do when we come to practical chemistry. Practical chemistry is important to say that is divided into qualitative analysis. Qualitative analysis. This qualitative analysis is what we call the SWOT analysis. Then it's also divided into the quantitative analysis. What do we mean by qualitative analysis? Qualitative analysis simply means an analysis that requires you checking if a particular cation or anion is present or absent in the experiment. Now, you have a particular salt sample and you are asked to check whether maybe so-so cation is present or absent. Your work there is to comment from your experimental results that this is present, this is absent. You can also comment that this is confirmed. You understand? Trying to show that you have high assurance that this is what present. Are you getting it? Yes. So in qualitative analysis, we use the word is it present, is it absent, is it suspected, is it confirmed. Okay. Then for quantitative analysis, we are checking the quantity. At what quantity is those cation or the anion present? That is what we do. Or a particular element we are looking at or you are looking for. At what quantity is it present in that sample? Yes. So this deals with present, absent, suspected, confirmed. Why this deals with quantity to get it. Now, it is also important for us to see how this can be classified. We can classify quantitative analysis into the classical method, classical and the instrumental methods. Now, under the classical method, we'll have gravimetric and volumetric. Gravimetric analysis and what? This one is volumetric analysis. Now, it is this volumetric analysis that you call your titration. Now, this gravimetric analysis is further divided into three. What are they? Here, we'll talk about precipitation. We'll talk about volatilization. Precipitation, volatilization, and electrogravimetric. Now, what do we mean by precipitation, volatilization? It means that when you are talking about an analysis that will result to formation of a precipitate, it means you are doing precipitation. Or formation of volatile substances, it means you are dealing with volatilization. Are you getting it? So these are for the gravimetric analysis. Then this one, as we said this is this acid and base titration. You understand, the one that you use your indicator to what? Do the experiment. Even some of these other ones, it requires some indicator, but it may not necessarily be the normal one, so to speak. Then this one is also divided into three. Here we'll talk about electrochemical method. We also talk about spectrometric analysis, electrochemical analysis, spectrometric analysis. Then we also talk about chromatographic analysis. Chromatographical analysis or chromatographic analysis. That means these are methods: electrochemical method, chromatographic methods, spectrometric methods. So these are the possible experiments we can do in practical chemistry. You understand? For your secondary school and year one, that is for higher institution, year one and secondary school, you have met qualitative analysis, the one you call SWOT analysis. Then in your year one, you have also met this qualitative analysis in a higher way. Then you have also met volumetric analysis both in your WAEC secondary school time and your what? Year one. But these other ones, as you come up, as as you come up to higher class, you will meet some experiments that will require you embarking on these methods. As we have seen on the board, this question is question on gravimetric analysis. That means in this experiment or in this question we are to solve, we will see what and what it have. That means we can see precipitation, the formation of precipitate and others. Okay, so we want to see how to solve this problem. Let's solve the problem, so to speak. Yes, let's solve this problem, so to speak. A sample of 1.24 gram of drug containing manganese was heated in a solution of nitric acid HNO3. The solution was made alkaline with ammonium hydroxide and excess H2S was bubbled through it. 0.29 gram of manganese sulfide was obtained. What is the percent of what? Manganese in the original drug sample. Find the concentration of manganese in ppm. Please, ppm means what? Parts per million. Parts per million. Parts per million. As we want to solve, we'll see how to sort it out, so to speak. Now, what is this experiment trying to tell you? Or what is this question trying to tell you? It means that you have a particular sample. Look at a sample, a drug sample. And inside this drug sample, they said it contains manganese. Manganese. So let's say the manganese is inside like this. Look at the sample containing manganese. That means, let's say we are talking about paracetamol, for instance, and the paracetamol contains manganese inside the paracetamol powder. Let's talk about what you have seen. Paracetamol powder. That means get the tablet, crush it, you get it in powder. Let's say now it's adulterated with manganese. You heard, wow, it was adulterated with manganese. And you are asked, oh yeah, check the quantity of manganese inside this powder. That brings you to gravimetric analysis. And for you to be able to check it, you need to ask yourself, what do you know about manganese? One of the things you should know about manganese is that manganese has intrinsic property to react with nitric acid. That is why they heated it with solution of nitric acid. And so you need to represent what happened or what you did to see how to know how much manganese is in it. You need to represent it with a well-balanced stoichiometric equation so that all of us will be able to understand what is going on. Look at what I mean. This is manganese 2 plus inside it. So when I put nitric acid here, when I put the nitric acid inside this powder or this substance, every other part of this substance will not react with that nitric acid except what? Manganese. Because manganese is what will have the ability to um, react with the manganese, so to speak. So we now say plus what? Nitric acid. When this react with this, look at what it will give you. This will take this to be giving you what? Manganese nitrate plus hydrogen gas. This hydrogen gas will evolve out, will be given off because it is a gas. So once you just pour nitric acid into this for manganese to react with it, you just notice a gas evolving into the atmosphere. Phew! Are you getting it? That is it. Then they said the solution was made alkaline with ammonium hydroxide. So when you react it with what? Ammonium what? Hydroxide and what? H2X and excess H2S. They say we are forming manganese sulfide. How are we forming the manganese sulfide? The manganese sulfide is being formed by taking this manganese with this sulfide. Then we'll be having manganese sulfide plus, then we take ammonium with what? Nitrate. Ammonium nitrate. Then what will remain is hydrogen now. Hydrogen and oxygen plus water. This is possible outcome we can get. Now we need to balance the equation. This one was given off, is already in the air. Then this one now, what you will do is that here we have 2. I will put 2 here and I will put 2 here for this ammonium hydroxide. I'm just balancing the equation. That means 1 manganese, 1 manganese, 1 sulfur, 1 sulfur. Then 2 nitrate, 2 nitrate, 2 ammonia, 2 ammonia. Then oxygen is 2 and here is 1, I put 2. Hydrogen is 2 plus 2, 4. Hydrogen is 4. That means we have gotten our outcome. Now this is a what? A precipitate, like a precipitate settling down at the bottom of the reaction. Are you getting it? So once you have gotten this, it means that you need to compare. That means 1 mole of this end up giving you 1 mole of this and end up giving you 1 mole of this. I will say 1 mole of what? Manganese from my well-balanced equation produces 1 mole of what? Manganese, and also produces 1 mole of what? Manganese sulfide. Are you getting it? I will just take this because this is what I need. I need to know the quantity of this. I need to talk about this well now so that I can solve this question, the percentage of this in the drug sample. Now what I will do now is that since they gave me this, I will check what is atomic mass of this. This is 55 gram per mole. This is 55 gram. Then this one is 55 plus 32. Sulfur is 32. Atomic mass of sulfur is 32. Manganese is 55. So 32 plus 55 will be giving you 87. So here is about 87 what? Gram per mole. Are you getting it? This one 55. That means we have to tell them that 55 gram of what? Manganese produces 87 gram of what? Manganese sulfide. Then 0.29 gram of what? Manganese sulfide will produce X. And how do we get the S? You use your calculator and cross multiply. You just cross multiply. Cross multiplying, we have this times this divided by 87. 55 times 0.29 all over what? 80 what? 7 equals to 55 times 0.29 divided by 87. We'll be having 0.183 gram. That means we have 0.813 grams of manganese in that sample. That means our total drug sample is what? 1.24 gram. Then manganese content of it is 0.183 gram. Then the additive, let's call it X. Remember, the question did not tell us to get the additives. Yes, but in case you are asked to get the additive, what you need to do is you say the additive, which is X, is equals to 1.24 gram minus 0.183 gram. You subtract 1.24 minus 0.183. That will be giving you 1.057 gram. That is the additive. That is this other excipients that is not manganese in that drug. That is just it. But the question number 2 says, find the concentration of manganese in ppm. Find the concentration of manganese in ppm. ppm means parts per million. ppm means parts per million. What is the equivalence of 1 parts per million? 1 parts per million is equals to 1 microliter over liter and is equals to 1 milligram over kg and is equals to 1 microgram over liter, and so on and so forth. Are you getting it? Now, which one should we use now? We have our answer in what? When we did concentration. When we solve the percentage of this in original drug sample, we said mass of manganese all over total mass of drug. Total drug mass is equal to 0.183 gram all over 1.24 gram. That is what we had before we now say percentage will be equal to times 100 over 1, right? Okay. Now, since any of this is equivalent to 1 ppm, what it simply means is that let me change this numerator to be in milligram, change the denominator to be in kg. To change gram to milligram, you multiply by what? 1000. So if I multiply this by 1000, what will I be having? I will be having 0.183 times 1000 equals to 183 milligram. All over, if I divide this by 1000 to get kilogram from gram, you divide the gram by 1000. If I divide by 1000, I have 0.00124 kilogram. Okay, then you now check it out with your calculator and get the full figure it will be. That means the answer is 14750.6 ppm or 14750.6 milligram per kg. Since ppm and milligram per kg are the same, that is one way to get it in ppm. Another way to get it to ppm is I will come and I will say, let me get my percentage. Percentage, that is the percentage of manganese in the drug, is equals to 14 point, we add it to be, let's do it so that I will not make mistake, divided by 1.24 times 100. That is 14.758.1%, which we approximated to be 14.76. Are you getting it? Now, a way of getting the ppm now to ppm can be gotten by taking that concentrated one, I mean the percentage of that manganese, take it and multiply it by what? Multiply it by 10 raised to the power of 4. That 10 raised to the power of 4 is constant. That 10 raised to the power of 4 is constant. That will be giving you what? 1, 2, 3, 4. That will be giving you 14,7581 ppm. And you know this one, if you approximate it, it will also be 81. So that is in ppm. So this is how to get in ppm. You can use any of the, depending on the parameter you have or what they represented the substance as, if it is a mass or in volume or whatever. For this one, you are talking about volumes, but this one is a mass. That is why we are using this one. If they are talking about volume, we would have used this first one. Are you getting it? So you just get the equivalence of this milligram per kg, you have it in ppm, or you get the percentage of that substance, of that cation or anion in the drug sample, or the percentage of that adulterant in that was drug sample, in that sample. Then you get the percentage of it. Once you get the percentage of it, multiply by 10 raised to the power of 4. Once you get the percentage of that adulterant in the total sample, multiply by 10 raised to the power of 4, you have it also in ppm. So that is how to solve this problem on practical chemistry. If you find this video interesting, if you enjoyed it, please give us a like. Yes, share to your friends. Click subscribe or follow us on our page. Follow our YouTube or subscribe on our YouTube. Even on Facebook, we are there. Yes, you can also follow us on Facebook. This is my Facebook name, Chidons Daniel. Chidons Daniel. This, when you click Chidons Daniel on Facebook, you will see my page. My page is called the Chidons Group. The Chidons Group. You follow me up there. Then on TikTok, Chidons Daniel is my name on TikTok. You follow me on TikTok. Follow me on those platforms because we post a lot of things there. Thank you for watching today's video. See you in next class.